Hello, everybody. Welcome to night two of module four. It's 4 of 8. So when we finish the lecture tonight, that means we're basically halfway through the class. It 8-week courses go quick. Got a couple things to talk about tonight. Some more stuff with object-oriented programming, which I believe will fit in, should be able to fit in before the break. Mostly the next steps after what you should have seen in the prerequisite for this class. Getting a little bit more into inheritance, and we'll talk about abstraction, which kind of like some other things, kind of like private. We don't have true abstraction, or depending on the language, true virtualization of our software in Python. We don't have true abstraction, but we have a module that gives us that effect, and we can write abstract methods and set our inheritance up a lot better. But it really it's useful, but it's most useful for C programmers jumping over to Python because they might be used to doing abstract things. For those who know C++, put it in the header file, but it doesn't show up till 3 subclasses later when you actually use it. For those Java or C# programmers, abstract or virtual keyword. Something like that. But talk a little bit about inheritance and object-oriented stuff. And then we'll get into some basic database stuff. We're not going to do much more with the SQL than write the table or create tables, put some data in the tables, query the tables. And our textbook uses this library called SQL Alchemy. And I believe both of the videos that are video tutorials that are in the homework this week also use SQL Alchemy, which is just a module that allows us to use Python syntax to manage the database. A lot of people like that, but I learned SQL way before I learned Python. So I'm very comfortable with SQL, with the SQL syntax. So I usually go with that. And we don't have similar libraries in other languages. I tend to do stuff in the C family of languages most often, but and we don't have things like that in the other languages. So I'm just quite used to writing SQL syntax. We'll see that planning after the break. But if we run short on time for the database stuff, that assignment will get pushed back. The tutorials, this week you get a choice of tutorials. Let me pull that up while I talk about those. Then we talk about a couple homework assignments, so I should probably log in and point at them. So it's the homework out of the book will get pushed back. And while the follow along video tutorials also use SQL Alchemy, they don't do any explanations or anything. They just say type this code. So I was thinking that one might not necessarily need pushback because it's just following along. And if anything, it'll be Monday before we talk about that. But when I was getting prepared, practicing and all that, it seemed like it was going to fit. But y'all have probably noticed by now I'm easily distracted. And practicing the lecture by myself is not the same as giving the lecture. Usually way more focused for that part. Let's see, so in modules, because I also noticed that the homework distribution between module 4 and module 5 is not very even. And I was thinking about pushing things back. So this week we got our first Django thing, and I did update the instructions. They basically, it's what we did Monday. Remember last Wednesday we created the project and did that, if you need to refer back to that part. And then on Monday we looked at a template, and then we previewed what's going to be on your final project where you're getting stuff from an input and doing that. But just fill out a template. Like if you need a quick idea, use that introductory discussion board. Just modify that so that it spits out to a Django template and looks nice on a web page. I'll put quote marks on that because style is not a requirement in this class. Black letters on a white background counts as look nice there because it's not the console. Put it on a web page instead of the console. Basically, it should be a quick modification. If you haven't seen HTML before, let me know. But just that first part, I will leave it up to you to choose something. I should probably put it in here. Have at least 5 spots to fill in. That seems reasonable, right? you can choose what the data is about and the template, but please fill in at least 5 placeholders. Couldn't think of a word. Placeholders on the HTML template. Alternatively, I did leave the old instructions, so if you just want to go to that comprehensive tutorial. But every time I've taught this course, I was the first person to teach this for Ivy Online, and every time I've taught it, that comprehensive tutorial has just overwhelmed people. It's turned into way too much. So we're going to back it off, and basically what we do, and we're going to do what you're expected to know for an introduction to Django in the 8 weeks we have, because we have it's very short amount of time, and it's overwhelmed people, and it really starts, especially in the Ivy Online shell, where the only thing I can't modify is point values. It counts for a lot of the grades, and it tends to hurt people when that difficult tutorial messes them up. In our course, I modified the grades so that the Django stuff doesn't count for that large of a percentage. It kind of blends in nicely with the rest of the assignments, as opposed to being 2/3 of the course grade. Missing one of those is like missing a regular homework assignment. Or 20 points, it's like missing one of the programming assignments, not even the case studies. Half of a case study. So that's the only thing we're not allowed to change with Ivy Online is point value. That point value on something that always seems to stumble people up really bothers me. So I left those in there, because depending on the path, you might want to go ahead and if you feel like you have time to go through it, you might want to go ahead and jump in and get that comprehensive introduction. It's still not the full picture of everything Django can do, but it's a lot more comprehensive than is required for our class, for the requirements of the final project. So I left those in there, but just do something like we did that first thing we did on Monday, where we just set up an HTML template and threw some data at it. Nice little easy introduction that way. Also this week, when I was reviewing it, there's a few things, and next week we're going to set up Docker and do a CI/CD pipeline, and then another small Django assignment, which is going to be modified depending on how much we cover in class next Monday. But there's a lot less homework here. CI/CD pipelines we'll talk about those next week. That's modern installers, right? And updaters and things like that. We'll talk about that. So we got Django, the modules and databases, and the object-oriented stuff from last week got pushed back. So this is going to get pushed back a couple more days, because we're going to talk about this evening. I think it was currently pushed back to the 9th, but I'll probably push it back till next Monday, which would be the due date for what we normally talk about on Wednesday. But this will be an important one. I want you to focus on, pay some attention to this, because basically the requirement is it can't be a common example. So like if you start Googling tutorials about object-oriented programming, you're going to see certain things, right? Object-oriented programming, Python. If you start Googling tutorials, I know within a couple of these, you're going to see a car, a shape. We looked at animals, that might be up near the top somewhere, not nearly as common as cars. I just don't want you to do one of the common ones. I want you to create your own thing. So something you're interested in. That's what this list is about. This is specifically things from former students. A custom gaming computer. A patient for a counseling service, because a former student was a receptionist at a counselor's office. So that seemed like a really good example of it. What does it take to represent that patient in the company software? A fishing pole. What behaviors and properties do we want in a fishing pole? Remember that donut picture the other day? Attributes and methods would be our technical terms. What attributes do we have about a fishing pole? Like how long is it? How much probably how much weight can it hold back? Is it for deep sea fishing, for river fly fishing, rivers, lakes? I assume there's different fishing poles for all the different things. I'm not a fisherman, but I know that the deep sea fishing poles are definitely different than the ones I see people like putting in their cars for around here to go down by the Ohio River to fish for a couple hours. A guitar, how many frets does it have? What type of wood is it made out of? Woods, there's almost always more than one type of wood. And the different attributes about that: electric, acoustic, what does it have? Coffee maker, try to generalize it. So this one I just added to the list because I've been improving my coffee setup. So like in my office right now, there's a drip maker, a French press, a pour over, percolator pot, and then a pressurized thing. It's a cheap one, so I don't like to use the word espresso, but it does build up a lot of pressure and have to compact your grinds and everything, but it's cheap, so I don't like to use the fancy Italian word for that. That usually makes me think of like the $3,000 machines, at least the $30,000 to $30,000 coffee makers. Not those, but what do all coffee makers have in common? They're going to have certain attributes that we can apply to any coffee maker, and certain behaviors that we can have applied to just any coffee maker. So what attributes and methods are going to be our technical terms, but what properties and behaviors do these things have that we need to represent in our software? A fire hydrant. My car is parked right by the fire hydrant today. It's painted, right? What color? You're going to have a color, a pressure, amount of pressure. Right? We might not know what that is, but we know that that's under pressure. Probably a location or a list of buildings that it's close enough to be a useful fire hydrant. But just think about, I want you to actually think about something instead of following a common example on those. In some versions of this, I say, check with me about an idea first.
Yeah, you do.
Did I say that here?
Lower, yeah.
I erased it in some of them and put it, I can't.
The last pointer.
Oh, okay, yes.
Coffee, below the coffee maker.
Oh,
Yes.
yeah.
Yes. Yeah. So yeah, please check with me about the idea, because the biggest thing I'm looking for is it's not a common example. It is purely your thought, which also means it's going to be graded differently. It's comments, not points off for things, if that makes sense. Because a lot of the other stuff we'll do in class, there's tutorials that are at least very, very, very close to it. But this one, I would like you to step away from that, and we're getting ready to see some of that, and we'll do an example of something. I don't know what. I'm probably going to make an example of immediately. Module 4. Get this one out. So a couple of assignments this week. And APIs. These are follow along videos, and you can choose one of them. The statewide core shell has Flask API. It's been around for a while. It's very, very popular. It's a lightweight framework, so it'll do all the stuff we want from a framework, but it's much smaller. Django's for big projects, Flask is for small projects. But we haven't had concurrent processing in Python for very long. That is actually a very, very new thing. Multi-threading, and once we have multi-threading, then we can do parallel processing. And I don't think they even make single core processors. I don't think they've made single core processors in a long time. So once Python was able to do multi-threading, which is the necessity in order to do parallel processing, we have to be able to split our program up into threads before we can put those threads on different processors, different cores. Once Python could do that, one of the first modules to come out and was really, really nice is Fast API, which basically modeled on Flask, because Flask has been very popular for many, many years. When you're typing the code, and most of those differences are in the background, when you're typing the code, the difference is when you're passing parameters, and one of them you use angle brackets, and then the other one you use curly braces. Other than that, it's really hard to read through some code and tell whether you're in Flask or Fast API. So Fast API was modeled after that, but it can handle multi-threading, which multi-threading is what's necessary in order to do parallel processing. And we will see those here in a couple weeks. So I included that, but you can choose either one. The follow along videos. The one from Flask is by, is his name showing up on there? Pause the video. Oh, let's get this. This guy, people really, really like this guy. If you haven't stumbled across any of his tutorials, Caleb Curry. When people watch his videos, they seem to really, really, really like his videos. He does great tutorials. And the other one, I don't know this guy's name, but I looked at something that I was looking at the timestamp when I picked another one, and I'd seen this guy before. So I was like, oh, that's about the same amount of time as the last video. So just choose one of them. Time allows, walk through both of them. Maybe it'll help you understand a little bit better. They're basically doing the same thing and just modify it. So like in the Flask video, he's CRUD is the standard server operations: create, read, update, and delete. The four main things we want to have a client needs to request from a server. The things we do with data. Transfer, we set up new data, we read the data, we update or overwrite the data, or we delete the data. So our four main functions, so we're transferring it back and forth, follow along videos, and they do, like he does a bunch of sodas, grape soda and cherry soda and stuff. So for your homework, just change it to a book, is what I put here. But if you want to, if you have that custom class that we just talked about, if it would make sense to, if you want to use your custom class, if you have some nice things in there, make sure it has an ID, like it would go in a database, and then use the properties from your custom class. That will be acceptable as well, but change it from what the videos are. But those are follow along, and they use SQL Alchemy, but it is just type this code on this line and follow along exactly. So we'll talk about that Monday if we run out of time tonight. But I think we'll get to it. Yeah, then the discussion board. And next week is Docker. We'll containerize stuff using Docker. That's the most popular container stuff. And once we have a container, we can set up a continuous integration continuous deployment pipeline, which those two things sound really fancy, but they are not. Or they are really fancy. They are really fancy. They are short amounts of coding. Samantha's done these assignments before.
Yeah,
they don't take long, right? Yeah. This is the same one we did in last summer. So that is GitHub, not GitLab version. So it's super easy. I love a bit of the picture. So it looks like a lot, but you generate the code and delete a paragraph. Delete the paragraph that wants a security certificate, because the only security code key we have at this point is the one that we use to log into GitHub, which we can't use on the software that we deploy. So in order to avoid going over all that, I said generate the code and delete the last paragraph or the last block. So it's a super easy assignment. Mostly it's just concepts about them. But in the real world, like, we don't write that code. We have GitHub or something generate that code for us. That is the standard way to do it. But even though the list looks long, these things are all a lot shorter than these things. So if we need to push something back, next week is when we'll get everything back on track. And this one's going to be pushed back further. Yeah, custom data class is going to be pushed back further. Does everybody use the calendar when they're checking dates? Since dates change, the calendar is probably the best one to check here.
Okay.
Just to let y'all know, that way you don't, because a module 3 assignment is going to be due next Monday. So the calendar here is really useful, and if you haven't used it before, it's got the calendar feed, so you just copy the URL over into iCal or Google Calendar or Outlook Calendar, or whichever calendar you normally use. calendars are standardized, so we can sync them all together. And this one knows about all your homework assignments and stuff. So actually turn that on so you see it. There we go. It looks, there we go. It looks like that. And when things get submitted, it crosses them off for you, which is really nice. And that crossing it off carries through to your other calendars as well. That's probably the place to check since our due dates keep changing.
The only bad thing with that is with the discussion board, it'll cross it off with the first one. So you have to know to go back and do the reply.
Yes. Remember to do your replies. Those are worth points. I do make it 2.5 points per reply, which if you don't do the replies, I chose that number because I put you with a C. It's like, oh, that's a really good post, but you didn't reply to your, you didn't interact with anybody, so that's like average for IT, right? Sitting in our own little corners, being antisocial. So, and then there's 2 due dates. So there is what did I do? I think a 2-point late penalty. Has anybody got the late penalty? No, I think everybody's already made their initial post by reply. So yeah, 2.5 points per reply, and then 2 points for the other thing. And otherwise it's pretty much a completion grade, but I read every word you send me even when I completion grade it. Not completion graded is I download it and run it and actually make an active attempt to break the software, find out where the breaking point is. There's always a breaking point. It might not be a bug, but there's still a point there's almost always a point that it could break. So that's the active grading. That takes a while. So every once in a while I completion grade, but I still read every word that you write, every comment, every line of code, everything on the GitHub repository. So it's not like just something was in the submission spot, so you get the points. I still read it and I give feedback. I just don't do the thoroughly take 20 minutes to find a way to break your software like I do when I fully grade things. Which, by the way, last week or on that loop one that showed up in the discussion board, a lot of the breaking point was a simple uppercase or lowercase z. A lot of people forgot to adjust, but please keep that in mind, right? If you tell users enter ZZZ when you're done, you need to adjust for the all capital Z's, all lowercase z's, or
Not lower the string.
dot lower, dot upper. Yeah. I usually go with dot lower myself. I don't know why. I almost always do that, but you get the same results, whichever one makes more sense. And then make sure you compare it to the right thing, because there's no telling what people might type, right? They might type capital Z, lowercase z, capital Z. Well, when you really get into it, there's people that might put spaces in there. They might put Z space, Z space, Z space. That at least, even the people that accounted for capitalization, Z space, Z space, Z space, still broke your thing, or Z comma, Z comma, Z comma. So it can go, I found a breakpoint on everybody's thing, but that first one, right, the capitalization, make sure you check that. Or keep that in mind. Okay, so now on to Python stuff. So picking up where we left off with the object-oriented stuff. Object-oriented is sometimes, it seems non-intuitive at first, but what throws most people off is that it should be more intuitive, and you're used to that lot, like the logic courses, breaking it down to algorithms the way the machine needs it. And with object-oriented programming, we can start to think like a human again. And that's what really throws people off. We reorganize our code so that we can think like a human instead of a machine. I believe I emptied out my delete folder, so I have to check that. I have to pull it down again. Yep, all I have is the other class examples. So I'm going to let's see, I'll just do it from PowerShell. Oh, we haven't seen Get GUI. So when you installed GitHub, or sorry, not Git. GitHub is just a website that runs the Git protocol. When you installed that, you should have got Get bash, which is a bash terminal to control Windows. Get command, which is a CMD terminal to control Mac or Linux. And get GUI, which is the default GUI application. So we want to clone our existing repository. So I'm gonna click this. The source location and target directory. Hopefully both of those labels make sense, right? What are we cloning? I want to clone https://github.com because there's a repository folder on there. Francis-Chris 5 /SDEV 220 spring 2024.git, or you can, that's the address you can just copy if you're not sure what it is off the top of your head. Over the years, I've learned to be very consistent with my naming things. Target directory, this one throws people off, especially if you're, this one throws people off because you want to choose the parent directory. So I'm going to put it in the delete folder. So I'm going to choose the delete folder. And then it will add this in. We have the same two boxes if we want to connect to a repository without a full clone so that we can pull things down in pieces instead of everything. And in that case, we connect to the parent directory. And then here we have to actually type a name because this software needs to create the folder it's going into. Just like if it's cloning, even if we're doing a pull so that we're only going to copy half of the repository down and pick and choose what parts we want, we go to the parent directory with the browse button, and then I have to actually type the name here. Clone includes typing the name. So I'm just going to hit clone. Oh, already exists. So do have to do it here. So I'm going to go to delete, and then this is examples. I'll put in an example called that. So see what I was talking about? It has to actually create the repository. So let's use this tonight. I'm gonna keep it open so I don't forget about it. Which, by the way, Spider for their Git integration. That's gonna be a project. Oh, well, you have to create a project, and then when you right-click over in the navigation pane on the left, which isn't showing right now, but I think everybody's seen navigation panes on the left of the text editor, right? Shows all the files. You right click on that, and then there's Git buttons, and those use the Git GUI that comes with Git source code management by default. Okay, now that we have those, I can choose the file explorer here, and documents, and delete examples, and here's animal.py that we created the other day, which should probably be in its own separate folder somewhere. Maybe I'll do that before opening it here. We have our repository pulled down. We can just make any changes. So here's that example from the other day. We're getting ready to extend it, so we should probably put it in a folder to keep things organized. So I'm doing a new folder. I'll just call it Zoo. Seems like a relevant name. And now I can drag in. Actually, it's probably quicker to do this. If I go back to the parent folder and back in, it'll re-alphabetize everything, and that file will be right next to it. Instead of dragging it way down, just one of them started with an A and one of them started with a Z. Patterns. There's a professor I had at IUS that really liked to always point out good programmers are lazy and they see patterns. So always look for patterns that'll make your job easier as you're writing code, or in general, everything you're doing. Okay, so now that that's organized, because we're going to extend it, let's open up that and look at what we were the other day. So here's our example from the other day, which for some reason this doesn't work, and I have a feeling I was making a mistake. Conversion factor 2.2. Let me just try it this time and see if it works. I want to divide by 2.2 because Americans are probably going to enter pounds, right? Kilograms are bigger than pounds, so we need to divide by animal, the class name, animal, parentheses here are optional. I'm going to take those out, and because we're getting ready to talk about when they're not optional, when we have to have them, when we have to or don't have to have. animal dot conversion factor, which is, oh, no error. Okay. Is that not what I did the other day? I remember I kept getting an error, but it worked on the first try this time. So notice that it's not self dot attribute. Anything self dot has to show up in the constructor in our init function. This one is part of the class, so we use class name dot class variable. But this right here is further than I've ever seen on a certification exam. Certification exams and technical places, all I've ever seen is they ask you to identify which ones are class variables and which ones are instance variables. Remember last week we had to create Fido, and then we could do Fido.age, Fido.name. We could do the instance variables, the stuff in the constructor, once we create an instance or an object. But this one we can access directly from the class. Okay, so that's better. So then we can get weight as weight. Oh wait, no, it would be right there. And weighs so many kilograms, because I don't know. I don't remember what I was doing, but I thought I did that right there, but apparently that is not what I did, because I was getting an error message the other day. And it clearly worked this time. Everybody remember this stuff from the other day? Just kind of looking at it for a quick review. I took the parentheses out. The parentheses show our inheritance. Parentheses are only needed if we need to specify what the parent object is. Animal, the only thing this inherits from is that object in Python. If we use parent-child terminology, object is the grandparent of all other things in Python. The ancestor, the descendant, all those parents and children lineages come down from. So we don't have to say that, it's implied. Any explicit inheritance goes in parentheses here. So we can leave the parentheses off here. We got a few things, got a name, an age, and a weight. Said age, said weight. There's something else that all our animals are going to do. And that's make some sort of sound. That's the standard. This is one of the standard object examples. So something animals do is they make a sound. So let's put that in as a method. Define make sound as the self parameter, and well, the sound is something that belongs to the animal, right? It's not going to change. We don't need that in a data field where we can change it. We don't need getters and setters. Dog's not suddenly going to go meow, right? Your box turtle isn't going to bark at somebody. The sound goes with the animal. What sound does our animal make? Kind of hard to say, right? The example Monday, we had a Fluffy and Fido and Mr. Gator or something like that. Kind of hard to define the sound. We know they're going to make a sound. We just don't know which one. This is where abstraction comes in. One thing we could do is say return roar. That seems like a good generic animal sound, but for veterinarian clinic, maybe a lion, but not a dog or a cat. Right? That's kind of, so we could do a default value and override it later in the child objects. Let's maybe do that once. So maybe we have a dog class. I'm going to come back and change that in a moment. A dog. Oh, let's do cat first. Let me do a couple. I'll go ahead and put up the ones I was trying to jump at. So let's do a lion. That inherits from animal. The lion comes in a veterinary clinic where this represents the software the receptionist is using. Is there anything we really need to change here? Roar would be good sound for somebody's pet lion or tiger or something. It's going to have a name, an age, and a weight. Getters, our sentence will probably be fine. I guess we could add something to there. and goes. I think this one will, it won't like this, self dot make sound. So I'll ask for that, but the F string, actually they might have fixed that. As I say that, I think they fixed that in 3.10. That used to not work, but it might work now. We'll try, we'll just put that in there. It makes the sound, whatever sound, right? Kind of fits with our representation of it. All that works for a lion. I don't think there's anything else we need to do for a lion. Just a good generic animal, right? And just say pass. We don't have to do anything except what we inherit from animal. Class cat. So like a small house cat. It also inherits from animal. It's gonna have a name, an age, and a weight. And do all this stuff. Cat's probably not gonna go roar when though, right? That's seems a little off for a house cat. So let's override, we want to override that method. So our constructor is good. We'll just use that parent constructor. Don't need to do anything special there, but we'll define a new method here called make sound. So we're overriding the one from the parent. Well, the self parameter, because everything has to have that self parameter in an object. And here we'll return meow. Without an exclamation mark, because it always seems to me like cats just kind of trail off the end of their sound. Like they want to say more, but they just can't quite get it out.
Unless
Or-
they're angry.
Yes. Sometimes there's an exclamation mark. I'll just put meow. It's a good generic one. But this still has everything it means to be an animal. We just change that sound that it makes. Maybe a dog as well. I'm going to add something to a dog though. So dog, it gets everything it means to be an animal. But I want to add a property. Dogs sometimes wear bandanas. I like to do that because that's a, like if I see a stray dog, I put a bandana on it because that is the best way to check if a dog is mean or not. And that way, because a stray dog running around in the city, little kids are going to try to play with that, right? So better find out if it's mean immediately. Yeah, I've been bitten by dogs before. I'll survive. Right. Don't tell officials that the stray dog bit me, but report it before little kids start playing with it. Oh, whoops, I spelled class wrong. Class dog has everything it needs to be an animal, but dogs sometimes wear bandanas. So we need to make a new constructor here. Whoops. Put my fingers in the right spot on the keyboard. In our init method, we have the self. We have all those things from the parent object. A lot of people like to do this if the list isn't very long. They want to say, put it in the same order, right? Name, age, weight. They'll do that, but we have another way we can do that. We've already seen it once. We have our new field, bandana, to be a Boolean, either true or false. And then args and quarks. So we'll have all of this stuff that we can pass up to the parent. And I really hope, in Spider, there's predictive text, there's dynamic predictive text. So I'm really hoping the thing I want to see on the predictive text shows up in a moment. Because a lot of people like to just type them out. That way it's easier to keep track of it. But I believe we will see it in the predictive text here. So when they give us a name, age, and weight, that just needs to go right back up to the parent object, right? So child objects do have special access. Right? These underscores aren't usually immediately accessible. Double underscore, we saw that the other day. But for the parent object, we say super, then we can access the init method. Goes with inheritance kind of nicely, right? Inherit stuff from a child has access to their parents' house. The internal stuff, not just the external stuff. There's more access for a direct child of the parent. in the real world as an analogy, and software is a similar way. There's certain a direct child has more access. So I think we need to pass up the self parameter. This one often confuses me. I'm going to type it, but it'll be obvious if we get it wrong. And for some reason, my mind thinks differently than whoever wrote the language, and I often have to come back and edit that. I think we have to pass that up, so I'm gonna do that. And then the args and quargs, which in our case should be name, age, and weight, get passed right back up to the parent object. And then we can set up our bandana. Self dot bandana equals whatever's passed in there. A true or false, right? Some sort of Boolean. Default values can be nice at times. So we could say like equals false for a default. And that way, if we don't pass in the bandana value, it's automatically false. And we can change it to true later. And it helps to make sure that that's there. The one thing you have to watch out for with those, let me scroll up here where we have a list. The default parameters with the default value have to go last. What's something else? So like per equals true. If I put that there, I get an error because the default non-default argument follows default argument. So the ones that don't have a default value have to go first because those are the ones that we can fill in positionally. But I was also going to make a recommendation against filling things in for positionally. Does that make sense? And args and quargs again is another situation just to pass all those parameters up there because right now we only have one level of inheritance. There could be 7 to 8 levels of inheritance and parameters added at every single one of those levels. Like those pictures the other day, we keep adding details. So as we get a few levels deep, there's going to be a lot of parameters in those constructors that we need to pass things up to. So it's kind of nice to have the pointers to handle that for us. And then we can override that method again. Define make sound, a different make sound than the parent, which would be self parameter and return, well, lowercase with an exclamation mark as opposed to our earlier work. That'll be good. Our string representation would still be good. There's a problem with that. We'll have to go back and change it, but we'll see that in a moment. Well, I can talk about it. Our string representation is kind of okay. The thing is, child classes inherit methods, but child classes do not inherit parameters directly, or do not inherit attributes directly. So when we say like, here in a minute, Fido, we create a Fido instance of dog and we say Fido.name, it's actually calling name from parent object, which has mangled data fields in this case. So we don't have access to those from Fido. So we should really be using the methods here. I'll go ahead and fix it. So instead of name, do we have a getter for that? Now let's put together a getter for name. Define get name self, and then that's just going to return self.name, which isn't there, but I'm just putting it there for good form. So when we say name, because we do have access, this one would work fine. Instead of that, we want to get name, and the child class will inherit that method. Instead of age, we want to do the get age, because the child class will inherit the methods, but not the attributes directly. Which in our example wouldn't make a difference because we can it's going to come down from the parent, but as examples get more complicated, it will make a difference. So you probably want to start using good form immediately because it will make a difference quickly. Okay, we can probably run this and do some stuff with it. Well, I'll type it in the main this time. So let's say Fido, is a new dog. Oh, I was hoping some stuff would show up in the predictive text. I was hoping name, age, and stuff would come down. So the question arises, where do we pass in the name? Where do we pass in the age? What order does it go in? Best form is just to go ahead and specify that. So then instead of remembering order, if we type it explicitly, the order doesn't matter. Like name equals Fido, age equals 7, weight equals 34, and bandana equals true. You can alternate that and pass it in positionally in the order that it's expecting those parameters in, which does go parent child, so it would go in this order right here. But sometimes that's not super easy to predict, especially when we have several layers. So just like those methods earlier, there's alternate syntax, but this is by far better. There's a lot of reasons to go ahead and hit those extra keystrokes. A couple extra keystrokes are easy, and if it gets off, it will cause major problems. So it is worth it to hit those extra keystrokes. Then we should be able to print Fido. Print Fido, make sure that works correctly. Oh. Descriptor in it requires a super object for received a dog. Oh, I forgot parentheses. I think is what that was about. Nope. Oh, maybe I don't need self. Is that the one I always get backwards? Let me try that. I still think it's supposed to have parentheses, but super object needs an argument.
It doesn't need the parentheses.
Okay.
Not set.
So we have something similar in all of our languages, but they're slightly different than that. Like some languages will have super with no parentheses. Python has super with parentheses. Sometimes this stuff goes into the parentheses. Sometimes it's dot and we have direct access to the constructor method afterwards. It varies language to language. So that's one of the points that's similar, but just slightly different in all our languages, which makes it hard to keep track of. You'll encounter those points as you program more and more, but notice how Fido is 7 and weighs not the number we passed in, but slightly less than half of that, which would be the kilograms, right? Yeah, half's a little bit easier. 2.2 pounds per kilogram. So
We should put in the 0.1F or
format that.
yeah.
So to format it, we can't use the F string. So what we have to do is, whoops, where's it at? Oh, wait. We break out of that F string, add in the format method, which is a special type of casting strings, and get rid of these curly braces. 0.1F in the format function, and then plus another formatted string. That one's a little bit unintuitive. It'd be nice if we could put that formatting inside of there. There's a way to, but there's multiple syntaxes. I think it was the first night we looked at that, right? Second night, we looked at a whole bunch of formatting things on the docs. Look for the syntax that makes the most sense to you. But the way I do the format of the F strings, we can't put this method inside of it. At least we couldn't last time I checked, which I haven't checked that since like 3.9. And in 3.9, we couldn't put the get weight method in there, but we can now. So Python is, like all software, languages update and change. Make sure you stay up on the changes.
Could you go up a little bit?
All right.
Yeah, that's yeah.
Okay. You want to ask out loud? Other people might have the same question.
No, I just wanted to see what did you do with get name.
With the get name? Yeah, just return name. Setters and getters always look like that. Getter is just return that, and setter pretty much always looks like this. Set, pass in a value, and then assign it to that value.
Why does it have two underscores before it?
That's called name mangling. You've had C++. That makes it semi-static. So it's a static variable, but static for the instance, not for the class. Since you've had C++, so everybody else is probably like, what do those words mean? We treat those as if they're private. Since we don't have private, that's sort of the Python programmers graciously treat other Python programmers code. If we see that double underscore, we treat it as private.
Double underscore is
It's yeah, treated as private. Technically, it's semi-static. So you see static in C++.
Yeah.
It means there's one and only one copy. Usually we, for the people on the Zoom call, because I know Sam's heard this as well. Static in the C family means there's one and only one copy, which means we can use the one in the blueprint, the design for the object. We don't have to wait for an instance of the object, which is absolutely necessary for the first step in our software, right? Because the very first line of code in our software, there are no objects to use. So the very first step at least has to be static. But Python, the very first step is way in the background, 50, 60 files deep. So we don't really use static stuff. So this is, it's kind of like that, only instead of using the class, it does adjust per item. But we treat it as private. We act like we can't access it. We act like we can't go Fido.age, right? Because it says we can't access age. But which makes it kind of like private. We get a message that says can't access it, but we can go Fido._dog__age. Maybe it's actually not dog, it's animal. Animal dot. I think I need a dot there. Go. No dot. So we can still access it.
That'd be
Age is an animal, so it didn't work from dog. But if we do _animal__age, so notice how it still kind of belongs to that class. That's the static part for those who have had C family languages. So we can access it, but we don't have private in Python. So it's just sort of an unwritten rule between programmers that when we see the double underscore, we act like it's private. Treat it as it's private, as if it's private. Whereas name we can access directly. Fido.name, we have direct access to the name field. You look confused.
And how did it still get access to age?
We referred to the class. So those two underscores before both mean something. They're not arbitrary symbols. One underscore checks the spot in RAM, and two underscores goes to the stack. So actually goes through the second underscore goes to the stack, and then the stack goes to the heap in RAM. Remember that diagram I drew up here, or a couple times, the stack heap diagrams?
Yeah.
That is really how the computers operate. So the first underscore goes to the stack, and then the second underscore goes to the heap. So those mean something. So we went to the stack, back to the animal class, or sorry. The first underscore goes directly to the heap, and then the second underscore goes through the stack to get to the heap. So we went back into RAM at where the animal class design was stored itself. And then we jumped over to see where the operating system was making use of that. Is those two underscores. If I can highlight it correctly. Where's the operating system making use of that thing, of this design? And when we get there, what's in the age field? So those aren't arbitrary symbols somebody picked. They mean something.
So whenever we want to access a private variable, we just need to use the class.
At one underscore class name, two underscores parameter and no dot on those. It's kind of hard to see there. There's no dot on. The dot is after Fido. But we have access, but usually we use that when we don't want anybody accessing that direction. Hence the getters and setters. Same thing would work with our cats and our lion, right? Let's say that's already ran, so it is in the console. So we could say Simba is a lion. Name, let me change the order. Weight equals, I have no idea how much lions weigh. They're more than humans, right?
Yeah. And
432 pounds. Probably more than that. Lions are big.
it was like 420 for a male and 280 for a female.
Oh. Weight is, oh wait, I already did weight. Age is 5 and name equals Simba. So notice also when we explicitly label each parameter that we're passing in, we get the advantage of the order doesn't matter. We just have to think about what we're passing in and not what order it needs to go in and what it needs to be. And we can print Simba. Probably no surprises there. Oh, I spelled Simba wrong. That's why. Print whatever that is. Sidna. There we go. So we got all that. The roar looks correctly there, but kind of an odd thing there with where we put this name up, because if we forget to overwrite that or something, if we're making lots and lots of classes and forget to overwrite that on, say, a box turtle, notice how we can keep making more and more animals, and we get all that, we inherit everything. So there's that picture. Let me draw a picture. Everybody seen UML class diagrams before? Probably had to draw some before. This is the oddest one to draw because it takes no thought to put the UML class diagrams together. Some of our other ones, data flow diagrams, activity, state transition diagrams, those take a lot of thought. UML class diagrams don't take any thought, so a computer can generate those all day long. If you write your code first, then you can just run your code through software that will write the UML class diagrams, and all you have to do is organize. Because the only thought is organizing them to make it look nice on a page, especially when they get complicated. So the standard is we have the name up at the top, animal, then our data fields. So we have a public data field called name, which is a string, :string. So notice plus sign for public, the name of that data field, a colon, and then the data type. Then we have a couple private ones. So we have age, which is probably an integer. I'm going to put int, but anything numeric would work. Then we have a private weight. I'm going to put float on that one, but anything numeric would work. In Python, numeric is a parent of all number types. So if we don't know if it's going to be integer or float or what it's going to be, we can just use the word numeric. We can use the parent. So that's polymorphism, right? We use the parent because we don't know which particular child we're going to be using come runtime. Yeah, I think that's all we have there. Then we have a dashed line, and then our methods. So we have our getters and setters. I'll just do the make sound. So we have a public method, so a plus sign for make sound. And in the parentheses, we would list any parameters. For Python syntax, that self goes in there, but self doesn't actually count as a parameter. Self only kind of counts as a parameter. Self is the thing we actually typed before. So it's actually self dot make sound. But when we're creating it, we put the self in here instead of out front. But we have that method, and then we should do a colon and say what it returns. That one's going to return a string. So there's our UML animal diagram. doesn't take any thought once the code's written, so computers can generate that part. And then computers can generate the code class because the computer can tell that there's things inheriting from that. It knows we have a lion class, which doesn't make any changes to it. And it knows we have a cat class, which overrides make sound. And then knows we have a dog class, so it can generate all of this. Most of the generators, though, especially the best ones, we'll put them right on top of each other because it does take thought to organize it. As we have a bunch of these and we have to organize them into a way that looks nice, that requires thought. Drawing the picture doesn't require any thought. Putting these labels on here doesn't require any thought. So computers are perfect for the things that don't require any thought. I think I made that public bandana, which is a Boolean. And then that's all we did on that one. So the UML class diagrams, that describes what classes we have. So usually we don't start from scratch, right? So this is something we want to include in our documentation. So if somebody else wants to use our objects, they know what is in there. So it's something we want to include. This one's easily generated. Along those lines, I was making the fall schedule last weekend, and in the fall, I'm going to start doing special topics every year. The next special topics one I want to do, which is going to be next fall, I want to do an open source thing. We extend open source. So we don't start from scratch, right? There's thousands of programs that already do something really, really close to what we want to do. That's the nature of open source. We just go grab that source code, and then we add the 3 or 4 functions that we're missing, that we need. So I want to do a class on that next fall. A special topics class on that next fall, if anybody's, for when registration opens for the summer and fall, if anybody's interested in that. Right now I'm planning on teaching that, but there's also an adjunct, one of the adjuncts that does open source stuff all the time too. So they may teach that so that I'm not in a double or triple overload again. I love this job, but I like it. I like not working 70 hours a week. I like not being in the office for 60 hours and then last weekend go home and work all weekend straight from when I wake up to go to bed. And it's nice to not be in the double and triple overloads, but that's a class I'm planning on putting together for the fall, and either myself or an adjunct that does project management and extends open source code all day long at their day job is going to teach that course. So, as I say that out loud, it sounds a little bit better if the adjunct teaches it, doesn't it? But that course is going to run in the fall whenever spring or summer and fall registration open. And this is one of the things we would study. We'd look at the class diagrams, figure out what objects are there, add our own objects to it, and what extensions we want to do. As far as us, we just need to be aware of a UML diagram and the symbols. So I'm getting ready to add another symbol. And then we're going to take a break. Actually, let's take a break and then we'll add the symbol. Because this one that I started to point out, roar is not a good sound. One of our animals made the sound roar, but in general, we can't really rely on that being the sound that can make. What would be nice is if we went ahead and had the make sound method, because we know we're going to have that method, and we use it immediately. Oops, trying to highlight this. And we use it immediately before we even instantiate this object. We're using that method. So we know we have it. We know we're going to have it. We just don't know what to put in it. And that's where abstraction comes in. So let's look at abstraction after the break. And databases is definitely going to be pushed back. The data on database is definitely going to be pushed back. But next week's homework, even though the list is long, is shorter work. So we'll balance out those pushing dates back. This is important. Yeah, this is a very important stuff. And the SQL coverage won't take us long at all. But 10 minutes sound good to everybody? Yeah, actually, tonight's lesson is probably the most important lesson at the 200 level because we get into abstraction and we won't see generics. We don't have generics in this language, but this point as the 200, 210, 220, 230, and 240 class. This is the object-oriented lesson is probably the most important one because that everything that comes afterwards, even if you go all the way to the doctoral level in computer science, everything that comes afterwards builds on object-oriented. Builds on this lecture, inheritance and polymorphism and abstraction. And in C family, we would have one more thing, generics, but let's take 10 minutes. My laptop says 7:13, so we'll get back to it at 7:23. See y'all in just a moment. Yeah, so that's why I don't mind pushing back that other lecture. This is the really important one. The other one is we're just going to look at using SQL syntax in our. We're going to use reference material for that anyway. So see y'all in a moment.